So let's talk about organometallic reagents, and this is something that shows up a lot more in organic 2 than it does in organic 1, but it's important to understand when it comes to nucleophilic substitution reactions at the organic 1 level with regards to alkyl halides. So there's two classes I'm going to introduce you to in this first video. The first is the alkyl lithiums and the other are the Grignards. So the alkyl lithiums, typically what we're trying to do is we're trying to displace something like chlorine on a substituted alkyl halide. And to do this, we're going to add lithium metal. We're going to add two equivalents. And what we're going to produce when we finish, well, we're going to draw it like this. We're going to say that this lithium has formed a bond to the cyclohexane in this case, and we form the lithium chloride. But this is really misleading. What's actually happening is that we have formed an organic salt. So our cyclohexane ring here has lone pairs, and it's ionically attached to a lithium plus 1 cation. This negative group, this carbanion, is a very good nucleophile. If it can find something to displace, it will do it, and will probably do so through a carbon-carbon coupling reaction. Now, reason you would want to do this is that this is an electrophile. It wants to get its chlorine removed. This case, this is an electrophile, or it's a nucleophile. It's looking for something to displace. So if you were to make this and then recycle it back with this chlorocyclohexane, you would actually end up getting a coupling reaction which would form two adjoined cyclohexane rings. Now, second compound we can make, organometallic, and this is a very big one, is we'll take an alkyl bromide and we'll add magnesium. And what the magnesium will do is that it will insert itself between the halogen and the organic compound. Now, this is going to have a similar effect, and the choice of which one we use, we'll talk about in later videos, is going to dictate what you're trying to do with them. But this is what's called a Grignard reagent. And these are super versatile compounds. Now, this is going to look similar to this in that this is not really what it is. We draw it like this, but really, we've once again got our carbanion and a positive cation associated with it. This is again going to create a very good nucleophile. It is something very good at coming along, taking those lone pairs, and binding to a carbon that's a very good electrophile. And again, if we were to take something like this, mix it with this compound or this compound, odds are what we would get would be the fused rings. So these are two big classes here of the alkyl halide, or the organometallic complexes. The alkyl lithiums and the Grignards.